Hey guys, welcome back to my channel. Today, I want to talk to you guys about loop engineering. I read LangChain's blog post and I built what they talked about pretty much myself using free open source models instead of paid APIs, and I had some bugs along the way. I just want to show you guys what actually works and go through the whole process with you. So what exactly is loop engineering? Now, the core idea is that agents get better not from a single prompt that's smarter, but from wrapping the entire agent in a loop that checks and corrects its own work. So there's 4 loops that LangChain describes in this blog post. The first loop is the agent loop, which is pretty basic. It's just, it calls the model and then it calls the tool and then it repeats. And that's basically the cycle of the first model. Now, the second level, the verification loop, has a grader that checks the output of the model against a rubric and sends it back if it fails. The third loop is an event-driven loop where the agent runs in response to external triggers like webhooks, not just direct user calls. And the final loop, the hill climbing loop, is basically a system that analyzes traces over time and rewires its own prompts to improve. Now, loops 1 and 2 are things that you kind of build yourself, and I'm going to show you guys exactly how to do that. But loops 3 and 4 need a little bit more infrastructure, so I don't really want to start that. Maybe in a separate video, I'll just sort of explain that to you right now. But yeah, before we even begin starting with any of these loops, I actually want to do a very simple tool call demo using a free model. So we're going to be routing this through Groq, and the model that we're going to be using is the OpenAI GPT OSS model. So let me just get that open. So in Groq, you basically want to create an API key. I'm going to do that right now. Call this YouTube and boom. Make sure to copy this API key and we can just go straight into our terminal and type it in. So make sure you type in export Groq and just paste it in. Okay, great. Now really quickly, the things that we need, the packages that we need are going to be LangChain, of course, and the partner package LangChain Groq. Okay, so now that we have those, let me just paste in the code and then we can walk through it step by step. All right, so this is basically what we have, right? We have a very simple tool that is defined as word count, and it just counts the number of words in a string. And what we want to see is we want to see this agent take this prompt, recognize that there is a tool that can be used, and invoke the usage of that tool, and then respond back to the user. So how are we going to make sure that that's what's happening in the background? The way that I'm printing this is printing the type as well as the content. So whether it's calling the tool, whether it's calling the model, whether it's taking the human message, we want to be able to see all of it. If we just run it, it'll be probably easier to explain. So let me just go ahead and do that. All right, so as you can see, we have a prompt from the user, we have our AI's response to it, and what the tool is saying, which is 30. So we can see that the tool was invoked, the response by the AI, as well as the final result, which is the word count. So basically, this is just showing us that that's how it works behind the scenes. It sort of calls the tool when it needs to. All right, so how does this work within the context of this agent loop, right? This, I guess, if we go back to the blog post, is kind of like loop number 1. So this agent loop of sending a request to a model, it invoking the action on the tool, and then sending back the observation until, and sort of repeating that until we have a result. All right, but what exactly is the problem with this loop, right? There's nothing that checks if the output is actually good or verifies it. It just sort of does the thing and stops. So with loop 2, that's what we kind of want to fix. It's the verification loop. So how exactly do we implement that? Now, LangChain has something called rubric middleware. which is in beta, this API, but we're gonna test this out with our Groq model today. So for this, we can't just use the normal agent that we were beforehand. We're gonna create a deep agent. And what we want to do, I'm just going to follow the example given in the docs, but again, implementing this Groq model instead. All right, so the example in here is asking the agent to write a find duplicates function, and a grader checks that against a real rubric using our run test suite. If we take a look at this code, we want to install deepagents. All right, so what this is doing is making sure that first this function is defined, and then we have these 4 different tests. So basic, empty, no duplicates, as well as this final one that usually catches the bug, which is unhashable. And what we're saying is we want to try all of these tests against our find duplicates function. And if there's an error, we want it to loop back and make a fix until it fixes that error. So how are we doing that? We're creating this deep agent, and we're passing the tool, which is run test suite. And in here in middleware is where we're passing this rubric, and we're saying that we want it to use that tool, and that at max we want 2 iterations. And finally, we're just invoking this specific agent and passing this rubric to it. And in this rubric, we're mentioning that we want it to pass specifically run test suite. So let's go ahead and see what this would output for us. While that's running, let's just talk about the different rubric verdicts that we have. So if you look again on their page, they kind of explain it. There's satisfied, which means that it doesn't loop back, everything in the rubric has passed, and needs revision is usually what happens. The agent runs again. And then of course these other cases, which are failed or max iterations reached, where the loop sort of gives up after too many tries. So you can't, I think with free models, it's kind of hard for it to loop forever. But yeah, I guess that's a limitation. And then there's grader error, which means that the grading step itself broke in some way. So initially, before I was using Groq to sort of provide that free model for me, I was trying to use a Hugging Face endpoint instead. And when I came to the step of using the rubric middleware, I actually faced an error. Essentially, the error that I was facing with Hugging Face was it was saying that there should be exactly 1 tool. But I was giving it 2 tools, and I was confused because the only tool that I was passing was the run test suite. But the reasoning behind it is that the grader needs to return a structured verdict to the agent. And to do that, it silently adds an extra tool behind the scenes. So combined with my test runner tool, that's 2 tools. And here's sort of a forum post. But yeah, Hugging Face chat wrapper only allows a forced tool choice when there's exactly 1 tool. So that's a limitation, I guess, in the specific iteration. And I tried moving the tool around, and it still sort of broke. So I just switched to Groq because I didn't face the same error with it. So yeah, I just stopped routing through Hugging Face's layer, and I called Groq's own API directly, and they have more tool calling support. Okay, let's take a look at this output. So I gave it 1 task, which is to write this find duplicates function, and it can't actually call this task done until that whole test suite passes. So the first call over here is the AI. It's making a tool call to this run test suite, and it's passing the code that it's written. And in this first attempt, what it's doing, it's writing the function using the set to track the items that it's already seen. And that's the normal way that you do this. But when it calls run test suite on its own, that test fails, which you can see right here. It says the tool, and it says that it's failed, and it's because of this specific test, this unhashable test, because it's a list. So Python sets can only hold hashable things like numbers, strings, or tuples, and they can't really hold a list. So one of my test cases, this unhashable test case, actually passes in a list of lists specifically to check for this. So the first most natural way to write this function kind of breaks on that edge case. But it doesn't just give up. the test failure gets fed back into the model and it rewrites the function this time, and it passes it back into that run test suite tool. And this time, instead of using sets, it's using plain lists and checking them manually with a loop. So now finally you can see over here, it returns okay, true, and that there's no failures. So all 4 cases, including the one that it broke the first time, now pass. Now that's pretty much the loop. It writes the code, it tests it, and if it fails, it actually fixes the underlying issue instead of just guessing again. So that's the difference between an agent that just produces an answer and one that verifies it. So that's pretty much it for this video. Let me know if you guys want to see a deeper dive into loops 3 or 4, or maybe even a completely different topic. That's all for me, and I'll see you guys in the next one.